This is Algebra Lesson 9.4, Fitting Exponential Models to Data. Example A says, consider the equation y equals 15 times 1.2 to the power of x. What is the percent change? So percent change is related to what is this ratio in here. So if I see a ratio of 1.2, I am going to multiply it by 100 to turn it into a percentage. You can also think about just moving that decimal 2 places, but that brings me to 120%. Then we're going to subtract off the original 100%. That brings me to a 20% change. So this equation models a 20% increase. If your answer ended up being negative, that would tell you that it's a decrease. Evaluate the equation when x equals 10. I'm going to substitute 10 in for the power right here. So that is 15 times 1.2 to the power of 10. Um, 15 times 1.2 to the power of, where's my power of button? There it is, power of 10. Gives me 92.9. Let's round that. So that definitely tells me it's increasing too, because if my starting value was 15 and after 10 terms I'm at almost 93. Letter B. The table at right shows the number of atoms of a certain element as it decays. Calculate the ratio of atoms remaining between successive years. So what that means is I'm going to take this value and divide it by the term in front of it. So I'm going to do 78 divided by 100, and that is 0.78. I grayed this box out because you shouldn't have an answer there. So we're going to keep dividing the number by the one in front of it. So I'm going to go 65 divided by 78, and I got 0.83. 52 divided by 65, 0.8. 39 divided by 52, 0.75. And lastly, 35 divided by 39. I'm going to round that one to 0.9. So if you remember, when we did this before, we were getting nice ratios every single time the ratio was the same, so it was really easy to put that number in the parentheses. But now, with real-life data, you don't generally get the same answer. You're going to get a variety of answers. Hopefully they're close, but not exact. So if I have all of my ratios, check, I'm going to use the average ratio as the value that I'm going to actually use for the rate of change in my formula. So average means add them all up. And then divide by the number of answers. I have 1, 2, 3, 4, 5 ratios there, so I will divide by 5. So my average ratio is 0.812. So now if I want to write an exponential equation, that's y equals the starting number, also known as the zero number. And then my ratio, we're going to use the average ratio, raised to the power of x. Letter D, use the model to predict the number of atoms after 10 years. Very similar to example A, part B. We're going to substitute 10 in for the power of that equation. 100 times 0.812 raised to the power of 10. And that is 12.5. I don't know my unit. I guess it's atoms. 12.5 atoms. So we started with 100. After 10 years, we're down to 12.5. That's it for the notes on this lesson. Good luck on the exercises, and please let me know if you have any questions.